Morning, seventh grade. Welcome to the second lesson of Unit 3, Algebraic expressions. Today's lesson is simplifying expressions by using the properties of operations. So we're going to shorten that a little bit for everybody on notes. But really, it's all about, we're starting to identify two of the properties today, associative property and commutative property. And notice how we can use those to help us simplify expressions and make it easier for ourselves to combine like terms. Because again, our end goal is simply what we went over in that first lesson, combining like terms. And we need to make sure that we can identify like terms before this, but that's what the review is for. So please make sure that you're doing the review. Okay, let me share my screen. All right, so as I said before, our title today is going to be simplifying with properties of operations. And there's two strict properties I'm going to go say. Underlining is U3, L2. Today is 11/2/20. It's 7 a.m. if you want to put that up here. All right, so we're going to start by just going over the properties of operations. And there's actually a whole bunch beyond just these two. I'm going to do that little squiggly line for subheading. All right, there's four main ones: associative property, commutative property, distributive property, and identity property. There's a couple others as well, and we won't worry about the distributive property or the identity property today. But what we're going to start with is the associative property. Associative property. All right, what the associative property tells us is that the way numbers are grouped or associated, but it's called the associative property, where the numbers are grouped or associated, does not change the result in addition or multiplication. What this means, some examples. 5 numbers, that means I can have 1 plus 2 plus 3, and that's going to be the same as 1 plus 2 plus 3. It doesn't matter if the 1 and the 2 group together or the 2 and the 3 group together, it's going to be the same thing. 1 plus 2 is 3, plus 3 is 6. 2 plus 3 is 5, plus 1 is 6. They're both equal to 6. Okay, if I wanted to use variables, do the same as a plus b plus c is equal to a plus b plus c, parentheses. All right, so parentheses, when we're doing addition and multiplication, don't matter, okay? Unless we're talking about distributive property, which, again, I think we remember from last year, but we'll go over tomorrow. But parentheses don't really matter too much. Number 2, second property you gotta worry about today. Not just the associative property, the commutative property. Commutative property. It has that word commute in it, which I think we're all pretty familiar with the word commute. You know, your commute's like how you get to school or how you get to work from home. Your commute is how you move to somewhere. Commute means move. So what the commutative property tells us is that the order of numbers does not change the result in addition or multiplication. Well, if we're talking about order, why is it called a commutative property? Well, again, it's because the numbers can move or commute. So because the numbers can move around, which is another way of saying commute, that's why it's a commutative property. So for example, let me just stop screen sharing for 1 second. All right, I just need to make sure I'm still recording. For example, we could have 1 plus 2 plus 3. Now it's going to be 1 plus 2 is 3 plus 3 is 6 again. Or we could have 1 plus 3 plus 2. 1 plus 3 is 4 plus 2 is 6. Again, it does not change the result. Okay. This is the same as A plus B plus C equals A plus C plus B. All right. Now this is the way that we really need to apply this today, and why this is so important for us, is in actually simplifying these expressions. How are we going to use these properties to help us simplify these expressions? So we're going to have another little subheading here. Simplifying expressions. Again, a little squiggly line for the subheading. So where it matters is if we're given an expression like negative 3x plus, open parentheses, or minus 2x, close parentheses, minus 8. In this case, we need to apply these properties in order to simplify this expression. Well, the first property we can apply, because we have these parentheses here, is actually the associative property. Okay, because again, the associative property tells us that the way that numbers are grouped or associated does not change the result. So what that means is you just get rid of the parentheses. You have plus, you have minus. Okay, well, this is the same as adding negative 8. So it's all adding. So you can just get rid of the parentheses. So let's say this equals negative 3x plus 4 minus 2x minus 8. And again, that's because of the associative property. Now, next idea, what do we want to do? Well, we want to group like terms. We want to put them next to each other. Well, the reason why we can put like terms next to each other is actually because of the commutative property. The order of the numbers does not change the result. So I can identify my like terms with my circles and my boxes. So I do. And I can rearrange them using the commutative property. So now I have negative 3x minus 2x, I have another minus with it, plus 4 minus 8. Again, I rearranged it because of the commutative property. Now, our last step is simply going to be following what we always do, combining like terms. So let's just put that explanation over here, combining like terms. And negative 3x minus 2x, well, negative 3 minus 2 would be negative 5. So I'm going 2 back from negative 3. And that's just going to be x, negative 5x. And positive 4 minus 8. 4 minus 8 is negative 4. That's the same as minus 4. So negative 5x minus 4 is my final answer. And again, I found that by applying the associative property, by applying the commutative property, and then by combining like terms. Again, you can pause it here any time to stop and take these notes. Please make sure you have these notes. They will need to be uploaded by Tuesday, so it's a little bit of a shorter deadline than this weekend. I'm going to quickly go over the I-dos as well, and then you should do the we-dos. I'll automatically tell you if you read not informative. Please let me know when I'm with you guys for the second part of the class if you have any questions about any part of the we-dos or any part of the I-dos and notes. I'm happy going over any of it. And if you have a question, I'd probably like to go over it with everybody remotely, because I think you'll probably have similar misunderstandings. I'm not sure what we'll address in class that I won't be able to get to here. But please let me know. I'm happy going over anything. All right. Looking at these items. Item number 1, we're given a bunch of x and y's with different fractional coefficients. Now, remember, when we're adding and subtracting fractions, we need to have a common denominator. And we need to identify like terms here as well. So I have 3/4 y plus 7/12 y plus 1/5 x minus 3/10 x. Box those. All right, so I'm going to use my commutative property for my like terms next to each other. I have 3/4 y plus 7/12 y plus 1/5 x minus 3/10 x. Now that I put my like terms next to each other, I need to find common denominator if I can add and subtract my fractions. 4 and 12, well, that would just common denominator would just be 12. So 7/12 y can just stay the same. What I get from 4 to 12 times 3. 3 times 3 is 9. 3/4 y is 9/12 y. Now 5 and 10, oh, that can just be 10. Okay, so 3/10 x can again stay the same. But how do I get from 5 to 10 times 2? 1 times 2 is 2. Now I combine my terms, 9/12 plus 7/12. 9 plus 7 is 16. So 16/12 y plus 2/10 minus 3/10. 2 minus 3 is -1. -1/10 x. 1/10 can't be simplified, but 16/12 can. They can both be divided by 4. That's 4/3 y minus 1/10 x. Always box it to show my answer. Notice especially too, because normally I go straight down. But here I had to go slightly across in order to fit on my page. So I boxed it to make sure I knew exactly what my final answer was. Final answer was 4/3 y minus 1/10 x. Right, again, the process that we followed was we first of all identified like terms. Then using the commutative property, we rearranged them so like terms were next to each other. Then we found the common denominator. Then we either subtracted. Then we simplified if we had to. We did have to here. All right, going on to item number 2. Item number 2, notice we have n on top of these fractions, which is a little weird. And it's next to this one over here. And we have 2 different kinds of terms, some n's and some constants. One of the things to note when you think about this, if you have n on top of a number, that's the same as just that fraction times n. And when it's n by itself, remember that's 1n. So it's really 1n over 3. So this is the same as 1/3 n. So first of all, let's just identify like terms. Okay, I have n here, n here. Let's try to get that minus. And here we should get a plus, box. I'm going to rearrange it. N over 3 minus 2 and 2/9 n plus 5n over 6 plus 15 minus 2.5. So these two probably rearrange it. All right, now let's put into a form that looks the same. So 1/3 n minus 2 and 2/9 n plus 5/6 n. Again, n over 3 is the same as 1n over 3, so just 1/3 n. 5n over 6 is just 5/6 n. Plus, what we can do, 15 minus 2 would be 13. Let's see, 15 minus 2.5. Okay, so, well, I gotta have something here. I don't have anything here. So let's do 14. 2 over 2, because I took one whole out. 2 halves minus 1/2 would be 1/2. 4 minus 2 would be 2. We don't 1, 12.5 plus 12.5. Right now, common denominator, well, 6 and 9. That's interesting. Can't be 20. Can't be 12. 6, 12, no. 18. Be 18. We do 18. All right, 3 times what is 18? 3 times 6. 1 times 6 is just 6. 9 times 2 is 18. 2 times 2 is 4. 6 times 3 is 18. 5 times 3 is 15. All right. Now, it's hard to think a lot of times mixed numbers like this. Let's make this an improper fraction, and then we'll change it back. Now you have 2 and 4 18. So 2 times 18 is 36. Plus 4 is 40. And you have 40 18ths. So 6 18ths n minus 40 18ths n plus 15 18ths n plus 12.5. Well, 6 minus 40 would be negative 34. 18ths n plus 15 18ths n plus 12.5, negative 34 plus 15. Remember, you can subtract them. 34 minus 15 would be 19, and the negative is a large opposite right, so it would be negative 19/18, and plus 12.5. Well, 18 goes in one time, so it's negative 1, and 1/18, and plus 12.5. So it is a lot of, wow, I totally wasn't even showing you guys those steps. What I just did, sorry everyone. So you would see up to here. Now I found that negative 2 and 4/18 is the same as negative 40/18. So just replace that, negative 40/18. Then I combine like terms, 6/18 and negative 40/18 to get negative 34/18. Then I combine like terms again, negative 34 and positive 15 to get negative 19/18. Then I simplify that by putting it into a mixed number, negative 1 and 1/18 and plus 12.5. All right, so a bunch of steps, but not too much work overall. It helps to keep it clear each and every time. First, we identify like terms. Rearrange it so the like terms are next to each other, okay? Then rewrite it so that all the fractions look similar, so that and in all these weird places. Then common denominator. Then, because it's helpful, change the mixed number into an improper fraction. Combine like terms, simplify. Kind of the same process every time. You gotta identify the like terms, rearrange it so it's next to each other, whether using associative commutative property or whatever. Then you gotta make sure that all the fractions look the same, including having a common denominator. It helps a lot of times when you're adding, subtracting mixed numbers to make them into improper fractions. You don't always have to, but especially when we have them as coefficients, it helps a lot. Then it's combine like terms. And that's kind of how we do it today. Please let me know if you have any questions. Please make sure you're getting straight to those redos and starting right on IP. Hopefully, you won't have much homework at all today. That'd be pretty great. Why don't we try and get all that finished today? It'll be plus 10 for anyone who can get the IP uploaded before the end of class. I'll give you guys plus 10. Well, maybe more, at least plus 10. But have a great rest of your day. Thank you everyone for sticking with me. Bye everyone. Bye, sound good.